Hi everyone, it's finally here. Today, we are excited to introduce Bantu, a platform that solves your home service. So, without further ado, let's get started. Okay, meet our team, our Bangkit Capstone team. Our team consists of 7 people. So, there's me, Dzikri Razzan Athallah, as the project manager from mobile development.
So that's me, Togar as mobile development.
Okay, next, it's me, Prabaswara Maharani. I'm from cloud computing development.
I'm Nalendra Faraz Putra Rahadyan as a cloud computing developer.
And there's me, Zeka, and I'm here as the machine learning engineer.
And then, it's me, Indra Mauludani Efendi, and project manager from machine learning.
And last but not least, there's me, Aditya Putra Afendi from machine learning engineer.
Ever had a lucky house that just one stop driving? Or maybe a flickering light that keeps you up at night? This little home problem can be a hack as hassle. That we are Bantu coming with just a few tap on your phone, you can easily book trust professional to fix your home issue. We are here to make your life simple, one service at a time. What is Bantu? Bantu is a mobile-based platform connecting users to verified home service professional with quick search, location-based matching, transfer fishing, and user review. We provide a simple, reliable solution that makes booking a home service easy and stress-free, just like the platform you are ready now, but focus on home repair.
Okay, now, so why we choose Bantu as our capstone project? Okay, here's the issue. 45% of home service requests are emergencies, causing stress and potential damage. In Indonesia, 56% of households need regular maintenance, but only 29% of homeowners are satisfied with how easy it is to find reliable providers. This shows a clear need for platforms that offer fast, trusted, and affordable services.
And so what does Bantu offers? We offer quick booking and location-based matching, so users can easily find and book nearby service providers based on distance and availability for timely and cost-effective service. And also we have a consultation service, which user can consult with providers to understand their needs and also get accurate answers. Not only that, we also offer search bar, where users can find the service that they want, and also a location tracker, which shows user the available services based on location. And also we have top handyman list, which gives user recommendation based on our AI recommendation model. Last but not least, we also have a nearby handyman list, which give user a list of nearby handyman.
Okay, this is how we made Bantu web. First of all, here are the tools that we use to make the app. There are Android Studio, Microsoft Excel, Railway, Google Cloud, Firebase, Postman, Figma, TensorFlow, VS Code, Flash, and the last but not least is Google Colab. And the dataset that we're using is Handyman dataset, which is our main dataset. This dataset was created by our team using synthetic data for analytical purpose, and it contains information about user needs related to handyman services, such as wall painting, electrical installation, or air conditioner setup. And additionally, the dataset includes user data, such as location, age, gender, as well as review and ratings of the handyman they hired. The handyman data covers their name, specialization, location, and gender. And this dataset is designed to simulate real-world scenarios and support data-driven application development.
And then, model summary. The model summary provides an overview of the neural network structure. The model consists of 3 main layers, 2 hidden layers, and 1 output layer. The first layer has 32 neurons with a real activation function, while the second layer contains 16 neurons with the same activation function. The final layer is the output layer, consisting of a single neuron that generates a prediction. A kernel prediction, a single scalar value. The total trainable parameter include the weight and less from a layer. This architecture is designed to handle numeric data and is well suited for regression tests such as prediction rating of preference.
And the next one, we will discuss about the training result of our model. So as you can see here from the picture down below, we have 20 epoch for both training data and also the validation data. We also use a training loss, which represented by MSE, mean squared error. As we can tell from the left graph over here, we have the graph steadily decreases, which indicates that the model is effectively minimizing prediction error on the training data set. Similarly, on the validation loss, it also decreases, albeit with more fluctuation, suggesting that the model is adapting to unseen data but may face challenges in maintaining consistency. And for our last graph with the model loss, we use the mean absolute error for both training and validation follows a similar trend, with training MAE consistently decreasing and validation MAE showing slightly variability. Both of these results indicated the model is learning well, but the fluctuation in validation performance highlight the potential for overfitting.
Next, we talk about authentication on Google Cloud. The cloud system we use for our application is combining Firebase and Google Cloud Platform to handle authentication and backend services. For Firebase, we use authentication feature to manage secure users login with methods like email or passwords or Google. Then for storing and syncing application data, we rely on Firestore as the main real-time database. Lastly, any file uploads such as image or document are handled using Firebase storage, which is both secure and efficient. On the Google Cloud Platform side, we use Cloud Build to automate the building, testing, and deployment for our application. We also leverage Cloud Storage as a scalable solution for storing assets like media files. And the backend is hosted by App Engine, which ensures that the application can scale and run reliability even during high user traffic. By combining these tools, we create a system that's secure, efficient, and scalable to meet our application needs.
Okay, for the next is machine learning or Google Cloud, and maybe the first one is cloud storage, where we store the trained ML model to the cloud storage, and this allows us to store the model securely and access this for serving prediction in our API. And the next is the Vertex API that we manage the machine learning platform on Google Clouds, and in the Vertex API we will enable to create inference endpoint that can process requests and provide prediction. And the third one is Docker file. Docker file is to build the API that will interact with the Vertex AI. We created the Docker file, and in this file will define the environment and dependencies for our API. And the last but not least is the Cloud Run. The Cloud Run is for the deploying the API, and once the API is containerized, we will deploy it into the Cloud Run, and mobile developer can now send the HTTP request to the API deployed on the Cloud Run, and the API will process the request, interact with Vertex AI, and will send the result back to the mobile app. Next. Okay, maybe this is for the cloud architecture. There is a storage, endpoint, API, scaling, and cloud function that we will use in this project.
Okay, here's a mobile developer sector. When user interact with the app, the journey begins in the UI. No direction, like tapping a button or selecting an option, are captured. This interaction triggers view model, which takes charge of processing the request and deciding what needs to be done. The view model then reaches out to use case, the heart of the business logic, to perform the required operation. To fetch the necessary data, the use case relies on the repository, which acts as a gateway to all data source. If the data isn't available locally, the repository retrieves it from the network using retrofit. However, if it's already stored, the repository pulls it from the local database powered by room. Once data is required, it flows back to the use case, which process it if needs and send it to the view model. Finally, the view model updates UI, ensuring the user sees the latest information. These seamless flows keep the app organized, efficient, and user-friendly.
Okay, so here's some demo application for our app. So here's some onboarding screen. And here where our register and login logic to use our app. And here's the main feature for our app. Here you can search by map, where's your nearby professional for your service. Also, there's a list of some professionals that created by us using our machine learning that implemented in our app. And here's some order status and order history that are deleted from our app. And here's our profile for our app.
Yeah, so I guess that's all from Bantu. Thank you for your attention and see you at the next appointment.